Freezing breaks rocks. Cold cuts down mountains in another way by freezing water in the cracks in the rocks. You've probably seen a frozen bottle of milk with the cap pushed up an inch or two out of the bottle. When milk freezes, it expands and needs more room. Water also expands when it freezes. When water changes to ice, it expands and needs more room. As it expands, it can push very powerfully. You can see how powerfully by doing this experiment. You will need 2 small bottles with screw tops and water. Do this. Fill 1 bottle with water right to the top. Screw the covers tight on both the brim-full bottle and the empty one. Put them in the freezing compartment of a refrigerator. After an hour or so, look at the bottles. You will find that in one bottle, the water has changed to ice and that the bottle has cracked. The empty bottle did not crack because there was no water in it to expand and split it open. It takes a powerful push to crack a glass bottle from the inside. When water expands as it changes to ice, it pushes with great force. The same thing happens during cold weather on a rocky mountainside. In the daytime, water from rain or melting snow flows into cracks and pockets in the rock. At night, when it gets very cold, this water changes into ice and expands, cracking off chunks of rock that add to the heap at the bottom of the mountain. Plants split rock. Plants have a part in breaking rock. Sprouting seeds, as they swell up with moisture, are amazingly powerful. To see how powerful they can be, try this. Experiment. You will need 1 package of whole dried beans and a screw-top bottle full of water. Do this. Cram as many beans as possible into the bottle. Some of the water will be forced out. Screw the bottle cap on tight and let it stand overnight in a warm place. You will find that the beans, which are seeds, will swell as they begin to sprout. By morning, they will probably have swelled so much that the bottle will be cracked open. The power to crack open the bottle came from the sprouting seeds, and in the same way, rocks can be split apart by seeds that fall into a notch or crack in the rock and then begin to sprout. The roots of a tree that began as a small seed can crack apart quite a large piece of rock. Many seeds all up and down the mountainsides work together to crack the mountain down. Plants change rock. Did you ever look at a big rock closely? Here and there on the rock you will find that flat grayish-green or grayish-blue plants called lichens. They look something like moss. Some lichens are so tiny that they seem only like colored fuzz on the rocks. Some are larger, but they all have a special way of being able to live on a rock. All growing plants need certain minerals that are in the earth. Most plants get these minerals through their roots from the soft soil. You know that these minerals were dissolved out of rock and soaked into the soil by rainwater, and that most plants take up their necessary minerals with water. But lichens have a harder job. They have to get their nourishment out of the solid rock. To do this, the lichens ooze out special juices that make the rock soft and crumbly. Then rainwater is able to dissolve the minerals in the rock so that the lichens can get them. As the lichens work at getting their minerals, they start the breaking down of rock on its way to becoming soil. If you can find a piece of rock with lichen on it, pull away a small piece of the plant and look at the exposed rock. You will see that it is slightly crumbly. Scratch it with a fingernail or knife, and you will find that it is softer than the part of the rock on which no lichens are growing. Wherever you see lichens, you're looking at rock being changed into soil. What is soil? When you take a walk in the country, you don't usually walk on chunks of rock. Occasionally, you see rocks jutting out of the ground, but most of the Earth's rocky crust is covered by soil and by plants growing in the soil. What is soil? How did it get there? You can find out by doing a simple experiment. You will need a small glass jar with a screw top and some ordinary garden soil. Do this. Pour a handful of soil into the jar and fill the jar with water. Screw the top on and shake the jar. Then let it stand for a minute or two. You will find that most of the material will settle to the bottom, but some of it will remain afloat on the top. Now do this. Skim off the floating material and examine it. You will find that it is dark and soft. If you examine it closely, you will find that it is made of crumbled bits of plant material, old dead roots, stems, and leaves. Now do this. Pour off the rest of the water and examine the material that sank to the bottom. You will find that it consists of grains of sand and small pebbles. In other words, bits of broken up rock. Soil then consists of plant material and rock material. The plant material is simply the crumbled remains of the plants of last year and the year before, and so on back for many years. Rock, bare rock, began to be broken apart by heat, cold, rain, and snow. Lichens grew on some of that rock. They poured their juices into the bare rock, softening it a bit at a time until it crumbled away. Then other plants were able to grow in the mixture of crumbled rock and old lichens. When these hardy plants died, they broke up into the bits of twigs and leaves that became part of the soil mixture. In this softer soil, more plants grew and rotted into the soil to become still more soil. Gradually, bald, rocky land was softened by weather and water, by plants and sunlight. Slowly, grain by grain, rock has crumbled into a thin mantle of rich soil. This coat of soil is shallow, only a few feet deep at the most. Yet out of this shallow soil that once was rock grow all the plants that feed us, all the green covering of the earth. Changing rock. Rock is everywhere in the world, and everywhere it is being changed. High up on the mountainsides, rock is split by the heat of the sun and cracked apart by freezing water. It is rolled and crushed by rivers of water and rivers of ice. It is crumbled by lichens and dissolved by flowing water. Over countless centuries, rock is turned into soil everywhere in the world. But the journey of the rock is not ended. It is never ended. In every tiny part of every living thing are minerals that once were rock that turned to soil. These minerals were drawn out of the soil by plant roots, and the plant used them to form leaves and stems, flowers and fruits. When the plant was eaten by an animal, these same minerals became part of the animal, and still the journey of the rock is not ended. For nothing in the world remains unchanged forever. A rock is not always a rock. A rose is not a rose forever. The fresh, crisp apple that you may eat today is as old as the hills. And when you eat it, a tiny bit of those hills becomes part of you. Just think of what that apple may have been before it became part of you. Once it may have been in the autumn leaves that fell and crumbled into the soil near the trunk of the apple tree. Years before, it may have been in the shell of a robin's egg, and once it may have been part of a stalactite in some dark underground cavern. Perhaps for a short while it sailed high over the earth in a butterfly's wing. Long ago, it may have been in a kernel of corn planted by an Indian. The things of the world are formed again and again out of the same materials of the earth. Nothing is lost. Over and over, these earth materials have been part of many things in many places. Today, when you eat the apple, these parts of the earth become part of you, who are part of the world. The land and the sea meet. At the coastline, where the land and sea meet, nothing is still. Rivers pour down with their cargo of soil and dissolved rock into the restless sea. You have seen that high land is hewn down to low land by many forces, and now at the meeting place between land and sea, there's another force that batters the land. Along the water's edge, waves roll in and beat against the shore, changing the coastline. If you have ever wondered how waves are made, try making a few yourself. Next time you take a bath, sit quietly until the water is smooth and calm. Then blow along the surface of the water. You will see tiny waves set up. The waves in the ocean or in a lake are made in the same way, by the action of the wind blowing over the surface of the water. As they beat against the shore night and day for thousands of years, waves cause many changes in the land. Some of these changes can be seen happening, while others take a very long time. Pebbles into sand. If you've ever walked on a pebbly beach with bare feet, you must have wished that all those sharp pieces of stone could be turned into smooth sand. Walk down to where the waves are beating against the shore, and you can see your wish being granted. As each wave topples over and smashes against the pebbles underneath it, it sends them clattering down against the other. The sharp points and edges of the pebbles become worn away, leaving them smooth and round. More smashing and clattering, and the rounded pebbles are cracked apart into smaller and still smaller pieces, until finally everything is worn down to tiny grains of sand. Of course, the waves don't grind the pebbles into sand overnight. To get a slight idea of how long it takes, try the following experiment. You will need an empty tin can with a top, a handful of large pebbles, and a sheet of dark paper or cloth. Do this. Wash the loose sand off the pebbles. Dry them and put them in the can. Shake the can vigorously, up and down 100 times. Now, pour the pebbles onto the paper. You will find that a few dozen sand grains have appeared among the pebbles. What does this prove? When you shook the can 100 times, you gave the pebbles more of a pounding than the waves give them in an hour. Yet you chipped off only a few dozen or so sand grains. How long do you think it would take to turn the pebbles entirely into sand? To give you an idea of how long, consider that a handful of medium-sized sand contains about 25 million grains. Of course, some waves are stronger than others, and some pebbles are made of softer rock than others, and seashells are still softer and crumble into sand more quickly. For these reasons, you can't really tell exactly how long it will take for the waves to turn that uncomfortable, pebbly beach into soft, smooth sand. However, to be on the safe side, come back in about 50,000 years. Waves on the rocky coast. Turning pebbles into sand is not the only work that waves do. Along high rocky shores, the waves keep beating constantly against the rocks until they have worn away hollow places along the waterline. This leaves the rock above the water sticking out in a kind of shelf. The waves keep wearing away the rock underneath until finally, with nothing to support it, the shelf comes crashing down to form a heap of rocks at the shoreline. A rocky coast doesn't remain like that forever. The continued pounding of the waves gradually breaks the boulders into smaller rocks, and then into pebbles, and finally into sand. The ever-changing coastline. High rocky cliffs are cut down, sharp points are beaten off, pebbles and seashells are thrown up by the waves and ground down into fine sand with rocks broken off the cliffs. At the same time, rivers come into the ocean and drop their cargo of sand and soil. Every moment of the day and night, the rivers keep pouring into the ocean, building up deltas and filling up bays and harbors. Bit by bit, the coastline is changed by the rivers that flow into the ocean and by the ocean itself. Working together year after year, the ocean and the rivers gradually change a rugged, jagged coastline into a smooth, straight one. Does it matter? Does it matter whether a coastline is wrinkled or straight? To the people who live and work nearby, it matters very much. Where the coastline is wrinkled, there are sure to be good, safe harbors. The harbors are good because they are deep enough for large ships to sail in, and they are safe because the curving land on either side protects the ships from strong winds. Where a coastline is straight, the bays are very few. The bottom is usually too shallow for large ships to come in close, and there's no protection from the storms. A good harbor usually means that many ships come, bringing goods, business, and easy communication to and from other countries. Along every coast where land and water meet, there are constant changes taking place. The waves pound endlessly on the shores and beaches, and every wave changes the world.